Picture yourself drifting through the silence of deep space. No planets, no stars, and no landmarks. You are moving towards a sphere of total darkness. Ahead of you, a perfectly spherical void blocks out the background stars. You are falling into a black hole. In most fiction, this is depicted as an instant, crushing death. But crossing this threshold is actually a survivable physical journey. The weight of this descent comes when you realize that your internal clock and your physical coordinates are about to detach from the rest of the universe. A black hole is the collapsed core of a dead star, a region where matter is packed into a state of infinite density. This model isolates the two main components, the outer boundary, the event horizon, and the central core, the singularity. These are not cosmic vacuums. At a specific speed and distance, you can orbit indefinitely without being pulled in. We know they exist because astronomers have photographed the shadows they cast against the glowing gas of their surroundings. Mapping the anatomy on a blackboard is safe. We are going to test what happens when you attempt to cross those boundaries physically. This is our view of Earth as the journey begins. It quickly recedes into a speck of light, leaving you in total isolation. You encounter the accretion disk first, a swirling maelstrom of trapped plasma. It spins at nearly the speed of light, generating highly energetic radiation that glows a brilliant, violent blue. The gravity here is so strong that it warps the path of starlight. This gravitational lensing folds the image of the disk's far side up and over the top of the void. Your senses are no longer reliable. Space and light are twisting so severely that the black hole is manipulating your perception of the physical world. If you were approaching a standard stellar mass black hole, your journey would end here because of tidal forces. Gravity weakens with distance. Near a small black hole, the pull on your feet is millions of times stronger than on your head. This stretches you vertically and crushes you from the sides, spaghettification. You'd become a continuous stream of subatomic particles. Your biological structure cannot survive that degree of physical distortion. But as you drift closer, that fatal stretching never arrives. You remain completely intact. This is because you are falling into a supermassive black hole, an object billions of times heavier than our sun. Because its mass is so vast, the event horizon is millions of miles wide. This scale spreads the gravitational gradient over a huge distance, making the change in pull across your body very gradual. This creates a paradox. The most massive objects in the cosmos are the only ones that let you pass through their boundaries unharmed. Imagine a colleague watching your descent from a safe distance through a telescope. To them, you appear to slow down. As you reach the boundary, your image freezes entirely and slowly fades to red as the light leaving your body loses energy. They never see you cross. Inside your suit, nothing has slowed down. You check your watch, and the seconds tick by at a normal, rhythmic pace. This is time dilation. The gravity is warping time itself, ending the illusion that seconds pass at the same rate for everyone. This fall permanently disconnects your timeline from the rest of the universe. By the time you travel a few more miles, thousands of years have passed on Earth. Everyone you know is gone. You have reached the event horizon. This is the point where light itself can no longer escape. Crossing this threshold involves no physical barrier or alarms. Is completely silent. The change is mathematical. Space is now so severely curved that every possible direction you can move points directly toward the center. Up, down, left, and right all lead to the same place. You are now in a region of space physically severed from the outside world. You are making your final approach to the singularity. Classical physics predicts this is a point of infinite density, where all matter is crushed into nothingness. However, quantum mechanics states that information, the physical properties of your atoms, cannot simply be destroyed. This text highlights the conflict. Our mathematical models collapse under these conditions. The equations produce infinities, that suggest our understanding of the universe is incomplete. Whether the core is a firewall of energy, a hologram, or a gateway to another universe, we don't know. Human scientific knowledge ends here. You move into the final, total darkness of the singularity. You have reached the absolute limit of cause and effect. At the very center of a black hole, the universe simply stops giving answers.